Hi everyone and welcome to lesson 6.5. This is our last lesson of the unit. We're going to continue to talk about data involving two variables, and remember when we talk about data involving two variables, what that is simply an ordered pair XY, where X and Y have a relationship to each other. And then we talked about, in a previous lesson, we talked about correlations and causality. So even when X and Y are highly correlated, it doesn't necessarily mean that X causes Y. Now, in this lesson, we're going to go a bit deeper into correlations, and we're going to look at assigning actual numbers to correlations. So we can use a number as sort of a score to see how well X and Y match up with a line of best fit. The first thing we're going to talk about are direct and indirect relationships. Basically, the difference between the two is that in a direct relationship, both variables change in the same way. So, for example, if X gets bigger, Y also gets bigger. In the example given here, in a circle, diameter and circumference are directly related. The bigger the diameter of a circle, the larger the circumference, which makes sense. We even have an equation for that. I just wanted to let you know that sometimes these relationships are not necessarily linear. So a direct relationship could look something like this. As X increases, Y increases, but not necessarily in a linear way. Now, relationships that are negative are called indirect relationships. So they do the opposite thing. As X gets bigger, Y might decrease. And a good example of that is when you're training for a race. So the number of hours you put in to train in your running are indirectly related to your race time, meaning that the more you run in your training, the more your time will decrease. Okay, so it could look something like, maybe like this. Okay, all right, so what are correlation coefficients? Well, really simply put, this is a number used to describe a relationship and its strength between the relationship of the two variables. For whatever reason, we use the letter R to represent this. That's not important, but what is important is knowing that R has a value anywhere between -1 and 1. So -1, all the numbers between there and 1 will represent a correlation. So if I were to kind of look at a number line like this, okay, we would see that the numbers would be random here. They'd have like no correlation. This would be a strong negative correlation, meaning looks like a line going down, or a strong positive correlation. Okay, so positive values of R means, that there's a positive linear correlation. Okay, so let's just write down maybe like a guide to describe the relationships as a number. So remember, these numbers here represent R. So if R is 0 to 0.19, we would consider this a very weak correlation. Okay, so that those dots, the scatter plot would look really random. 0.2 to 0.39 is weak. 0.4 to 0.459 is moderate. Then we have strong and very strong. Okay, now this is also true in the negative direction. We'd still say weak, moderate, strong, very strong, but it would be in the negative direction. Okay, so let's have a look. So when R is -1, this should be +1. When R is +1, we have a direct positive correlation. Okay, so I mean, what that means is the dots in this relationship fall exactly on whatever the equation of that line is. So none of them veer off. They're all exactly on that line. So if I had another set of points on this line, as long as the points are directly on the line, this would also be r equals 1. So it doesn't matter what the slope of the line is. What matters is that the points are actually directly on the line. So that would be a perfect positive correlation. In the middle here, we can see that this is really random. So actually here is our line of best fit, but none of the points are actually on it. So this would have no correlation at all, meaning that there's no pattern between X and Y. So here we go. This is going to be our R is -1, and it is a perfect negative correlation. Okay, so it is going down, but all the dots are exactly on that line. Okay, so when R is plus or minus 1, we say we have a perfect correlation, but most of the time the data isn't that perfect. Okay, so if I look at these two graphs here, I can see R has a -0.45, meaning that, you know, the points are loosely correlated and to this negative line. On the right here, we have a very strong positive correlation, positive meaning that the slope goes up. I remember in a previous lesson, we talked about if you look at how far away the dots are from the line, that should tell you about how strong the correlation is. So because these lines are really close, we have a positive, strong correlation. Now, how did we get the number 0.92? At this point in this lesson, that's really not important, but I'm going to show you how to use software to actually figure out the value if you're given a list of points. So let's practice. What do we think about these correlations? It says match the following correlations to this graph. Okay, so I can see that this graph looks really highly correlated. It almost looks like it's exactly on a negative sloping line. So I think this one is pretty obvious, 0.95. Now, if I look at the other two, I can see that the correlation is quite strong, but it's not perfect. And I have to decide between -0.82 and 0.85. I think the tell here is that one of them is negative and one of them is positive. This would be a positive sloping line of best fit. This would be a negative sloping line of best fit. So I really have only one choice here. Okay, so I would call this strong, negative. I would call, or actually very strong negative, and I would call both of these strong as well. This is strong positive, this is strong negative. Okay, so what I'd like you to do now is take a minute. You can either click on this link through your online lesson package or you can type it in. What you're going to do is play this fun game. Let me show it to you. So once you log in and create a username, actually you don't need to log in, you just create a username, you're going to get some familiarity with what the numbers, the value of R as related to a scatter plot by making some guesses. So with this one, I can see that my correlation is probably a little bit like moderate. I can see, the blank triangles here. I can see it's positive. So I'm going to take a guess. I'm going to say that maybe this is 0.55 and the true R is 0.74. So I was kind of way off. My guess was 0.55 and my difference was 0.919. So let's play again. This one looks even worse. And I know in my previous guess I was way off. Maybe this one is more like 0.55. Let's have that was actually pretty bad as well. So maybe I need to play this game a little bit more, but we can see that the true correlation coefficient was 0.37. My guess was 0.55. Let's do one more for fun. Actually, I don't think I can. Anyway, so take a bit of time and play with that for a little bit, and then come back to the video and we can carry on. Okay, so now that you've gained a little bit of familiarity with how to guess how to guess a correlation coefficient, now we're going to talk about how to come up with it on our own. And there's a really complicated formula that we can use. And honestly, even in the upper grades, you probably wouldn't calculate a correlation coefficient by hand. What you're going to do is use software to help you calculate it using your data points. Okay, so let's have a look. We're going to use Desmos to perform a linear regression. Now, what a linear regression is the process of finding the line of best fit for these data points, and then along with the line of best fit, you can calculate a correlation coefficient, R. So we're going to open Desmos. We're going to open Desmos. We're going to go to the graphing calculator. We're going to type in the word table. Okay? And in our table, we're going to put in our values. So if necessary, you guys can pause the video and put these in yourself. Okay, oops. Okay, so I'll notice that I can't actually see anything on my graph, but that's because my Y values are so big. So if I zoom out like a lot, I can see sort of a smattering of things right here. Not that it's terribly important to see them, but I would like us to have a look. So one way to change our axes is to click on the wrench here. And what we're going to do is change our x-axis. So instead of going from this really small number, I'm going to start at maybe -1, and I'm going to go up to maybe 6. Okay, and then from here, we could even get rid of our minor grid lines. Okay, and then from here I can see that for my from 0 to 5, I have a graph that looks like this. So I don't have to use a ruler or anything to find a line of best fit. What I can do is use Desmos. So what I'm going to do is type in Y1, and it automatically does the subscript for me there. And it knows that this Y1 is related to the table that we just typed in. And then I'm going to use this squiggly tilde, which is in the top left-hand corner of your keyboard probably. And then I'm going to do mx1 plus b. So what this is doing is saying, hey Desmos, can you give me, so this tilde means approximation, can you give me a line that approximates my x and y values? And that's what it's done. And as you can see, it's not perfect, so I wouldn't expect a perfect correlation. So luckily, this Desmos actually gives me the correlation coefficient, so it calculates it itself. So I can see for this one, R is pretty strong. It's 0.8827. So let's go back to our note. Okay. So I can see that my correlation coefficient is 0.8827. So I would call that, and if we want to go back to our table, we know that 0.8827 would fall into the very strong positive correlation. Let's go back to the line of best fit. Okay, so it tells me at the bottom here what M and B are. So the equation of my line is Y equals 11.74. We might as well round to 2 decimal places. X plus 120.81. So I can see that the slope here is 11.74 and the y-intercept is 120.81. So I've already written it in here. That is the line of best fit, and I didn't have to do anything. I just typed in the table and Desmos figured it out for me. So now what we can do is use the equation of best fit to predict what the profits will be in 2018. So if I go back to my chart, I can see years since 2009 is my X value. Okay, so what happens in 2018? So what this means is this is 2009, 2010, 2011, etc. So I know that 2018 would have an X value of 2018, subtract 2009, my X value would be 9. So now what I can do is just sub that directly into my equation of best fit. This is better than just looking at the graph and taking a guess. So y is 226.47 when I put that in my calculator. So now I can use my equation of best fit to predict what year the profit will reach 400,000. So I can put 400 in for y. And I will use my calculator. So I get an X value of 23.78. And with things like this, we should always round up, because if we're rounding down, we're not at a profit of 400 because these are years, right? So we need to be 24 years away from 2009, which will be 2033. All right. So now I'd like to pause. I want you guys to do this practice. So pause the video, give it a try, and I will have an answer for you in a minute. So pause the video, give it a go, and then come back and see if your answer is correct. Okay, everyone, to start this line of best fit, the first thing we need is a relationship between X and Y. So X will be minutes and Y will be a percentage charge. So at 0 minutes, which I'm going to call 9:02, okay, I'm 5% charged. 12 minutes later, I'm 19% charged. 8 minutes after 9:02, I'm 14% charged. And 20 minutes later, I'm 28% charged. So as we can see, this list is not necessarily in order, but that is okay. So what we're going to do is go back to Desmos. I'm going to start a new blank graph. I'm going to type in table. I have 0, 12, 8, 20, 5, 19, 14, 28. Okay, and again, I mean, I can see my points here. It's not really that important. But what I want to do is write in y1 approximate mx1 plus b. And I can see here that my correlation coefficient is actually really good. It's 0.999, almost 1. Would I round this to 1? No, just write out the 4 nines, and then we have to write down our line of best fit. So y equals 1.15x plus 4.96. And I'm just going to write the correlation coefficient down, even though we weren't asked to do that. Okay, when will Mr. Corley's phone be fully charged? So we we want our percentage to be 100. Okay. With this, I get x equals 82.64 minutes from 9:02. Okay. And does this answer makes real life sense? Well, I guess that depends on what kind of charger you have. This is 1 hour and 23 minutes, I guess. I think so. I usually let my phone charge overnight, but I think you could get to 100% in 1 hour and 23 minutes and I think that's pretty reasonable. Okay, guys, that ends our lesson and our unit. As usual, please finish the homework and let us know if you have any questions. Good luck.